Hello, everyone, and welcome to another live session at the Reactors. My name is Rav, and I'm the program manager here at Reactor London. Before we get into the session, please take a moment to read our code of conduct. We're all here to learn, so please be respectful, please be kind, and please be considerate. The chat will be open throughout, and we do encourage you all to participate and ask questions. We have a very exciting session today with Mark. We're going to be talking all about Power BI plays roulette at Monte Carlo. And I believe this is going to be a very, very interesting session. So with that, I'm now going to add Mark to the stream, who will take the lead on the session. Hi, Mark.
Hi, Rav. Thank you for that. And thank you for sharing my screen. Hello, everybody, and welcome to this session, especially because it has such an odd title, Power BI Plays Roulette at Monte Carlo. I mean, my first lesson from this is never have a pun in the title. I think a lot of people were thinking, what on earth is going on? So without further ado, let me just talk a bit about the agenda for the talk. And despite the frivolous title, what we have is actually a talk with some serious technical underpinning. What we're going to do really is all about kind of building models in Power BI, especially models where some of the inputs are uncertain. And we're going to do things with Power BI that it's not supposed to do. I'm surprised that there's probably some clause in the Microsoft agreement that kind of says you shouldn't do this, or get a call from a Microsoft lawyer. But the good thing about that is that we learned some things about Power BI that we wouldn't have learned before. And it brings home something to us. So how I'm going to start this, I'm going to start talking about the business rules, the kind of what the business analysts would talk about, how to play roulette. We just have to talk about that because that's the basis of our model. Then we're going to talk about Monte Carlo simulation. I'm going to give you a first example, nothing to do with the roulette, but all to do with a kind of classic Monte Carlo example of estimating pi, as in pi, the circumference of a circle pi. Once we've got that, we've seen the way Power BI can do that and some of the Power BI functions to do that. We'll go on to looking at roulette. I'll show you some examples of what I did, which will go badly wrong. And you can tell me if you're smarter than me, and you probably are, where I've gone wrong. And it tells us something about measures in particular that I never realized. And then once we've done that, we'll build this Monte Carlo method for roulette. Again, for roulette, it's maybe not the most obvious example, but the Monte Carlo method is very flexible, very useful. I'm just showing it with roulette because it's almost so simple to do. It's a good learning example, though there are, we obviously would use it for more typical examples in financial modeling. Right, let me get started and explain my pun. Many of you will know, many of you won't. Monte Carlo is two things. First of all, it is this place. It is a casino in Monaco. Monaco is a tiny principality on the Côte d'Azur between France and Spain. And it's where you can go in and play lots of games like roulette or blackjack or whatever. I must admit, I've never been in. But that's Monte Carlo for you, the place. Not to be confused with Monte Carlo, the mathematical method. And Monte Carlo is a method of taking something that we can't solve analytically and solving it in a brute force way by just running lots and lots of simulations, hundreds or thousands of simulations, and then counting up the simulations that have result A or result B, and then coming to some estimate that way. Now, with roulette actually being a game of chance, we can actually, well, better mathematicians than me will be able to work it out statistically, but it becomes very quickly, there's a whole class of problems that you can't work it out. So, for example, the Monte Carlo method was kind of originally thought about in 1946. There was a mathematician called Stanislav Ulam. He was recuperating in hospital from I don't know what, and playing solitaire all the time. And being a mathematician, he thought, how can I calculate the odds of me winning at solitaire? How many games? What's the percentage of chances? If I'm a good solitaire player, I'll win. And he realized that because there were just so many combinations of the deck and the cards and the way that they could laid out, it was impossible to do it in any kind of analytical way. But what he could do, if he had enough time, he could play Monte Carlo. He could play solitaire hundreds of times and then just count out the times he won, the total times he played, and divide one by the other, and that would give him an estimate. So it's a simulation. And what we see on this slide is a couple of things. On the left, is a from Wikipedia. It's an example which we will actually do later on. So it's using Monte Carlo to calculate the value of pi. What we've got is that little quadrant. We've created, in this case, they've created 24,000 random dots anywhere within that square, and with an X between 0 and 1 and a Y between 0 and 1. And then what they've done is they've colored the dots red if they're within the circle. They've got less than a distance of 1 between the origin here and the point. So this would be a point within the circle, and this would be the point within our circle. And if we do some basic maths, remember our algebra from school, the area of a circle is pi r squared, r being 1. So that is a quarter of a circle. So the area of the dots is pi over 4. The area of the total square is 1 times 1. And therefore, if we take the red dots and multiply them by 4, we'll get an estimate for pi. And so that's going to be the first example that we do. And then we'll go on to simulating roulette. I want to just talk a bit about the business rules, the model that we're going to build. And there's a couple of things in roulette. First of all, we've got this wheel on the left, and basically it's quite simple. You get a ball and you spin it, and it falls into one of these slots. Now, there are actually 37 slots. I want you to notice this slot 0, which is the house advantage. You can't bet on 0, but if it ever turns up on 0, the house wins. So that's why in these games, like in every game, you're always going to lose on average. But other one that it's got 36, I don't know the proper term for them, 36 slots where it could land from 1 to 36. And so what we do is spin the wheel, it lands in one of those slots. And then there's a board on a table, this thing on the right, and basically people can bet on they can bet on a number from 1 to 36, not 0. And if they put a pound bet or a €1, since it's in Monte Carlo, and they on a 1 and it comes up in the wheel comes up with a 1, they win €36. So slightly, and because there's a 37, that means on average we'll lose because it's a 1 in, the payout isn't as good as the odds. Again, people can, if they want to, they can do something else. They can say put them on reds, and if a red, there's 18 reds and 18 blacks, 1 green, they can bet on reds and they'll double their money if they bet on reds, likewise on blacks, evens odds, and so on. So quite a simple game of chance. And those are our business rules. Right. Let's start off looking at that classic Monte Carlo technique. And what I've got here is, if I go to my Power BI, is this one. So this is a technique that we showed in the Wikipedia page. And again, what I've done is I've created a square, visual with a square. It's basically a scatter plot. And on that scatter plot, I put 10,000 dots. And let's have a look at the code to do this. So I'm going to start with the code, and then maybe later on I'll go into detail about how this code works. I've got to create the data, and let's go to my data pane. And what I'm going to do here is I've got some data sets here. Let's have a quick look. So I've created a data set using DAX. And what I'm doing here is I'm creating 10,000 rows. And what I'm doing is then calculating a value, which goes from 1. I don't know where the 1 is, but it goes from 1 to 10,000. And then I've got a value of X, and X is a random number between 0 and 1. Y is a random number between 0 and 1. That's a random point on the square to put our point, X and Y. And then what we do is we calculate D. D is the distance from the bottom left-hand corner to the point. So what we do is, if you remember Pythagoras and all that, we square X, we square Y, we add them together and take the square root. And then what we're going to do is what we're going to say is basically if D is greater than 1, then it's out of the circle and it's If it's less, less than, otherwise it's in the circle. So what we've done very quickly is generate a table with DAX, which gives us a model of 10,000 points. If I just move that out of the way, we can see down here that we've got 10,000 points. And those 10,000 points, we've got a random value of X, a random value of Y. We calculate D as a distance from the bottom left to the XY point. And then we calculate if it's in or out. A lot of those seem to be in. Have we got any outs there? Yes, we have got some outs as well. Lovely. So what we do then is let's actually we'll actually build the chart from scratch. So what I'm going to do here is I'm going to come along and I'm going to create a scatter chart. On my scatter chart, I'm going to go to my table, and I've got my data in this DAX calculated table called square points. I'm going to put X, unsurprisingly, on the X-axis, and I don't want to aggregate it. I want every single row is a point, so I'll say don't summarize. And I'll do the same with Y. Drag Y on. And to put the Y in the Y-axis, I'll just say don't summarize as well. So there what we've got is we've got 10,000 random points. The final thing I'm going to do is I'm going to come along to my in, out, and I'm also going to put that on my legend, not in my values, that won't work, but in my legend. If you give it a moment, what we get is the ones that are in the circle. You might want to make this a bit more like a circle, have the same values, or light blue, dark blue. Obviously, I can change the colors. So what we can do then is we can do some calculations. And the first calculation is how many dots do we have there? And what we're doing is we're calculating the total dots. Count rows calculates the rows. Square points is the table. And so we count all the total dots, light blue and dark blue. Then the next thing that we want to do is we want to calculate the points that are in, which is the subset of those points, where we've got the in out is equal to in. So that's counting the light blue points in this one. And finally, what we're going to do is we're going to calculate our estimate of pi. And we've done the calculation. Basically, it's our points in divided by our total points. That would give us pi over 4. So if we multiply it by 4, we get an estimate of pi. And so what I'm going to do is I'm going to come along and I'm going to put a card on there. And I'm going to put my pi estimate there. And we can see what I'll also do is I'll come over here and I might make that to, maybe let's make that to 4 decimal points so we can see it change. And just prove it is random. What I'm going to do here is when it's finished, I'm going to refresh the data. That was going to, if I come along and go to home, and I click on refresh, that's going to rebuild that DAX calculated table. And we should get a slightly different estimate for pi. That's actually quite a good one. That's 3.146, 3.154. So as you know, pi is about 3.1415, something or other. So it's a good example of how we use Monte Carlo. And it's shown us a few things. Basically, what we do is we create a table, and that table has got lots of trials in it. We create those trials, we generate series. That's going to create something with 1,000 rows. And then what we're going to do is we're going to combine that with a single random row. Let me just take that apart a bit. And what I can do here, let me show you what we do. If we wanted a single row, this will give us a single row here. What we're saying is var, we're going to get 2 variables, x equals random. Random will turn a value between 0 and 1. Y, again, a value between 1. And then we can use this row function to put this into a single row table. We're going to have a column, which we're going to call x. That's going to have the value of our x value, a column called y, which called y, and a column called d, which is if we can calculate that. So if we look at that and look at our single random point, we can see that's what it gives us. It gives us this down here. Let me just zoom in a bit there. And so we get that. And again, if we were to refresh the data, I won't do it because it takes a bit of time. We get a different X, a different Y, and obviously a different D. And so what I've done here is I've said that I've also used this generate series. And generate series, let's actually show what that does. I'll come over to here. I'll build a new table. I'll call it my table. Not very original. And I'll just use generate series. And generate series will just create as a table out of nothing with 10,000 rows. And it gives a one column called value and a unique value for each from 1 all the way up to 10,000. If I sort descending, you should see that. You've got 10,000 rows there. So that's what generate series does. So that's the essentials of how we're going to use Power BI and DAX to calculate, to build our Monte Carlo model. Lovely. I'm going to put that away for the moment. Right, let's get on to the game of roulette. And there's a couple of things that I needed to do for roulette. I needed to create the wheel that you saw, and I needed to create a board. And this is where I was kind of bending Power BI in ways it shouldn't do. But it was interesting to see how far we could get it. So what I've done to create the wheel is I've created a donut chart. Well, first of all, let me just go back one step. I need some data and I need to represent the chart. So if I'm going to come over here, I'm going to bring this over here, back online. There we go. And what I've got somewhere, my apologies, I've got some data which represents the wheel. So the best way to do that, to show it me, is I'm going to go into transform data. I'm going to go into transform data. And what I did first of all was to bring in some data. And if you have a look at this source, basically this, I'll come and do change time. This is my roulette wheel. You can see it's data. It actually comes from GitHub. I'll put a link in later on. So one thing to mention as well, which I forgot at the beginning, is that all the Power BI files that I'm showing, I've made available on GitHub, the 2 Power BI files. I've also, this data set that is the representation of the roulette wheel is also on GitHub. If you have a look, you can see it's there. And I will put in a link. My apologies for not doing that later on. I will put in a link to that. So what we've got here is we've got 37 rows because there are 37 slots on the wheel. And we've got the color, whether it's green for 0, red or black. The roulette wheel kind of goes in a certain order. It starts with 0 and then it goes clockwise, 32, 15, 19, 4. And so I've got an order. So because I've got to put them in that particular order, I've got the number. And then I've got whether it's odd or even, a value, and whether it's, if you can bet on whether it's below or 18, above 18, and you can bet on the 12s, 1 to 12 as well. So we've created the roulette wheel, and that's all I'm doing there. So here is my first question for you. And this is where I went all badly wrong. I've got a roulette wheel here. I've created it as a donut. Now, one of the things I wanted to do with this donut is I wanted to spin the wheel. I'm going to just spin the wheel now by clicking on refresh. And it's refreshing that roulette wheel. And what I did was this. I wanted in my roulette wheel to be able to show the number. So I've got a measure when it eventually finishes called winning number. And this is the measure. I want you to have a look at this measure. And what this number does here is use this function called round between. Round between will give us a number randomly between 0 and 36. Equal chance of getting 0, 1, all the way to 36. And what I've done is I really wanted to be able to somehow color in the this donut chart, which is what it is, with the number. But unfortunately, if I click on my donut chart and come along, I can't do that. If I click on my donut chart, and if I look in my, go to my donut chart, that's lovely. If I look in my slices, unfortunately, what I had to do was click each individual one of them. I had to make red or black. There's no dynamic formatting. So what I've done is this. I've gone, and in the middle of this, I put a card, a visual that returns a single number. In that card, if we have a look, it's the field is win number measure. if I have a look, that's the one that I've just talked about there. And what I've also done, I've created this is actually a matrix to represent the roulette board. In the matrix, what I've done in my roulette wheel, I've calculated let's go to my roulette wheel. I've calculated a couple of columns. My column, that is where it is on the roulette board, and my row. So doing that, I can use row and column there to lay out my roulette board. Now, here's the thing. I've also gone to my roulette board and I've said let's go to my board. And I want you to notice that if I come and have a look at my where is it? I want to go to the background color of my values. I think my road head is specific cell elements. There we go. And I want you to notice I've got background color. If I have a look at that background color, what I've got there is that's on a measure called background color measure. And if I look at background color measure, what I've got is this definition. Basically, it's going to find out, it first of all gets it goes through each number on the board from 1 to 36. And basically it says if the board number is the win number, then it's going to be a blue background. Otherwise, if it's odd, it's going to be a dark red. Therefore, if it's even and it's not the winning number, it's going to be a black. So I thought my logic looked pretty good. And let me just bring the StreamYard up. 1 second. Let me just bring that so I can see the comments. I thought my logic was pretty good. And what I'm going to do is I'm going to do Power BI's equivalent of spinning the wheel. Let me just click on refresh. And I'm spinning the wheel. And I got this funny thing here. Let's spin the wheel and see what happens. Give it a second. So I've got a number 23 as my win number. That's in my chart, in my card in the middle. And yet on the board, it doesn't say 23, it says 9. And I kind of came along and I puzzled at that for a while. And I'm wondering if anybody looking at this can tell me, who knows Power BI a bit, can tell me what I was doing wrong. Maybe put something in the chat window. I'll see. So we'll see if there's anything in the comments. Well, for me, eventually I scratched my head and I realized what we've got here is the difference between measures and calculated columns. And my model of what was happening is that win number measure came along, it calculated a number, and then basically that number was somehow static. But what happens is this: win number comes along, a measure is calculated for every time it's needed on a visual. So it comes to the card, and what it does when it hits that card, it comes and says, what's win number measure? It'll run that and it'll give a value. It'll run it once, and then it'll give a value. And then it comes to here, and what it's going to do is going to run that measure 36 times, 36 separate occasions. It's going to run it for this mark here, for it's 1. I'll put that in green so we can see it. It'll run it for 1, it'll run it for 2, it'll run it for 3. And every time what it does, it runs a separate calculation, a separate one of that win number measure. And so it's going to it's a completely separate calculation of the win number to the one on the card and to every other position on the board. So sometimes we get this very strange thing. If I click refresh again, we might see it, where we actually get 0 win numbers on the board, or 2 win numbers on the board, or even 3, because it's doing independent calculations. And that brought it home to me what a measure is. It's a dynamic calculation that we use. So here we can see 235, and I'll just run it one last time to see if I can get 2 on the board. Again, this is all random, so you never know what you might get. There's a 1 in 36 chance of each of these numbers turning blue, and there we go. So no, we're still getting 15 and 22 different numbers, but we're still getting 1 on the board. So how do we fix that? So we fix it by coming to this static method. And here what I've got is I've got the same thing, but you'll notice if I click refresh, everything's going to work. And what have I done to do that? I'll give it a chance to see, and you'll see basically, hopefully, but when it comes, this should be the same number, 27 and 27. So if we have a look at here, what I've done is you can see I'm using the win number static. And let's have a look at that. And if I click on win number static, we see that it's this value, a max of win number random value. Let's have a look at that win number random table. So I'm going to go to my tables, and I've got this table called win number random. And what that table is doing, if I zoom in, it's creating a single table with a single row. It's using rand between. And again, but what it's doing is this time it's actually it's running it once. And it'll run it once when we refresh the data, and that number will stay. And it'll use exactly the same number on all the visuals. So that number there, win number random, is basically what we're using. We're using another measure there called static. It's got max because there's only one number. I could have used min, I could have used sum, but with the measure, we've always got to aggregate. So I've used the max there. So that taught me that if we are going to build a Monte Carlo simulation, what we've got to do is we've got to build it so that we do the simulation in DAX in a calculated table. Now, win number random table is fine. And if we wanted to press refresh 10,000 times and write down the numbers, we would get 10,000 numbers, and we could simulate that. But we obviously don't want to do that. That would take too much time. So what we're going to do is we're going to write a calculation to do that. And what I'm going to do is start off with trial base. So let's have a look at this DAX. So this DAX is creating what I'll do is I'll actually write it from scratch as well. We're going to create a table. We're going to use generate series, and that's going to create a table for us with value. We've seen value, one column, 10,000 rows. The column is going to be called value. And then what we're going to do, select columns, is going to take that table, and it's going to write it as, it's going to say, I'm going to select the one column, it's going to call it ID, and it's going to use the value of value. Not the best name. Let's have a look. So if we have a look at trial base here, and let's go and have a look. We get we get a value called ID. Let's just write that in a slightly different way, show off variables to show also the step. So what I'm going to do, I'm going to come over here, and I'm going to create a variable, and I'm going to click var, and I'll just call it base, and I'm going to make it equal to this here. And then I'm going to say, I don't want to generate series of that, but I'm going to generate series of base. What I'll do here as well, I'll call that a variable as well. I'll call it final. And there we go. And I'm going to return final equals select columns, ID value. And it would help if I put my comma in there. And I'm just going to return final. So what I've done there is just put in, I'll get exactly the same back, but I've just split it into two. And so we can see that we get a result there. It's taking its time because it's calculating everything, not just that table, but lots of others. We've got the 10,000 rows. But let me just show, if I return base, that's the original one. What we see there, we can see the result of the generate series. We've seen that before. We'll get exactly the same table, but it will be called value. So what we've done is we've created a base table with 10,000 rows because we're going to simulate that, spinning that wheel 10,000 times. Let me change that back. So there we are, we've got value. So let me change that back. Let's do something else. Let me have a look. So what we're going to do is we're going to do a trial now. Let's wait for that to stop. And what we're going to do is here, what we're going to say is this. We're going to say a trial. And what we're going to do is going to start with our trial base at 10,000 rows. And generate is a wonderful table function in DAX. And generates the second table in the context to the first. So it's going to run for each row in the first table, each of those 10,000 rows, it's going to run this. And what I'm going to do is I'm going to talk what it does. So it's each of those 10,000 rows. It's going to spin the wheel, get a number between 0 and 36 back. And what I'm going to say, my apologies, is that let's say I'm coming and I'm going to simulate me coming in every time. And what I'm going to do, very simple simulation, I'm going to bet on 12. 12 is my lucky number, and I'm going to bet on it all the time. And what this says is that basically if this win number, which we've got there, equals to 12, and the other thing I'm going to do, I'm going to bet €1 every time. So if the number is equal to 12, I'm going to get 36 euros back. So my win is going to be 35 euros. The €1 are staked plus 35 more. And if it's not 12, then I lose my euro stake. I might also want to try a different technique. Here's just a different one, paying out on 28. And so what I'm doing is I'm going to return, this will return a single row, and we'll show that in a minute. We've got a row here, and what that does is it returns the win number, and it will return the amount I get back, depending on my two different strategies, payout 12 and payout 36, payout 28. So what we end up with is we end up with a data like this. We've got odd. Let's have a quick look. I should have lots of different win numbers. There we go. I've got lots of different win numbers from 0 to 36. And if I, let's just say, choose, for example, 0, I should get roughly 136. So I've got 247 rows. And if I click on 1, I should have roughly the same number of rows. So 240, 250, that's 136, there, 237. It is a random, so it's going to change. And so that's my win number. Let me just clear the filter there. And then I've got my payouts of 12, which is going to be -1 most of the time, or 35. And then I've got my payout on 28. Great. And there we go. And then I might have another one. I think I've actually got a third one in there. I did trial again. Let me have a look at my trial. And I've got a payout on red. Yes, and I forgot to mention one. Where's my payout on red? I'm looking for. Okay, so we'll come on to that in a minute. Then what I can do, so I've got my data, I've got my numbers there. The next thing I want to do is I want to calculate this payout on red, and my problem was that I couldn't do it actually when I was generating this particular code, because at the moment when we're writing code like this, we want to look back at the wheel and find out if this color is red or black. And if it's red, we want to pay, but it would be very inefficient to put it in here. So what I've done instead is I come along and I then write a calculated column, and I'm saying basically, if I look at my model, what I can do, and beforehand I've set up my model here, so that this is my trial, and you can see, let me zoom in a bit. There we go, zoom in. This is my trial, and I've said basically I've put a relationship there between my trial and my win number. And I will take questions on why it's a bidirectional relationship. If anybody cares to know, that might be too much technical detail, but I'll take questions on that in the Q&A at 1:45. So we've got this relationship, and because we've got a relationship there, I can say in my trial, I can say that I'm going to come to here to my trial, and I can create a new calculator column, payout on red, and basically it's saying it's looking at the related value on the color on the wheel, and if it's red, I'm going to win £1. I get my euro back and another euro. Otherwise, I lose. So what's that I've done is I've then done these Monte Carlo trials, and I've got this data called trial. And if we were to have a look at it now, let's have a look at it and let's visualize that trial. Let's run it. What we see is this. We see that I've now visualized the trial. I've created this little bar chart at the bottom what you can see is all the wins. I've created a measure called number of trials, which just count the rows. So we can see that roughly we'd expect it to be 270 trials, because 270 is 10,000 divided by 37. Some are above, some are below. Notice that my lucky 28, on this particular occasion, I would be in profit because my 28 has run 319 above the expected 270. But did my 12 is right on the money with 270 trials. So what I've got here is I've got my payouts. And even though I've got my 12 is done the expected number, I'm still losing 280 euros over those 10,000 because of this green one here, because that's the house advantage. Whereas this time, in this particular case, even over 10,000 runs, I come out on top. Whereas if I do my red, it shows red again. I'm just counting the colors here. It shows red 4,830 times, slightly less than the 5,000, because there's this green that takes kind of means that it'll never be 5,000, and red is always going to be below that because there's only 3 colors. So again, if I run that, you'll see I'll get a slightly different set of numbers, a slightly different set of results. Let's run that. But still, the picture is going to be the same. Okay. Now, let's say that I do another, maybe more realistic one, where I say, basically, what I'm going to do is going to come over here, do a summer. Let's say every month in this summer, I'm going to go to Monte Carlo from the 1st of June all the way for 3 months to the end of August. And every month, I'm going to come in and I'm going to play those 100 steps of the wheel every month. Let's see how we would calculate that. So again, I've got this thing called summer trial, and I'm doing pretty much the same sort of thing here. I'm generating a series of values here, but what I'm doing is I'm saying for each of my dates, I'm going to create a set of dates between the 1st of June this year all the way to the last day of August. 3 months in Monte Carlo doing this. I'm going to say the summer trials, and this cross join is going to take each of those dates, about 90 dates, and it's going to summarize it with these daily trials. Let me just put 100, because 100 daily trials in there just to make it a bit faster. So every night I'm going to go in and I'm going to do 100 bets. And what we're going to do again is we're going to generate across those summer trials. So that summer trials is going to give me a row for 100 rows for every date. And then what I'm going to do again for those summer trials, I'm going to spin the ball, get my win number. In this case, I've just got payout 12, again, exactly the same as before. If I tick that off, and let's have a look at that. And here's the results. And some days, what happens is that we can see basically I've got the date on the x-axis, and we can have a look. If we have a look, we're going from the 1st of June all the way to the 31st of August. And interesting to me that on the whole, we always lose, of course. Gambling is for losers, and that's a mathematical fact. But maybe you can understand a bit about why people get hooked on this, because what happens if they come in on the 1st, they do very well on the 1st, bad luck on the 2nd, and do very well on the 3rd. So it's a kind of roller coaster ride, and they might not see the pattern that they're losing, because some days they do make, really good. In fact, you have some of their best days, 116, are better than their worst days. So that might explain sometimes why people do gamble if they have this sort of roller coaster ride. In the end, the odds are against them, but that's good. So what we've done is we've shown Monte Carlo technique applied to a kind of a frivolous example, which is playing roulette. But this technique is really useful. And what I will do during the Q&A, I'll wait till there's any questions. I'm going to stop in a minute. I'll wait till there's any questions, and I'll show maybe a more typical example, a realistic example, where there is a financial model. So I will, Rav, I will open it up to questions just a few minutes early, if that's okay. And while you're doing that, I will bring up my financial model. So are there any questions?
Yeah, that's great. So we have our first question from Christopher Roger.
Okay.
I've never seen Power BI before. Am I right in thinking it's more user-friendly version of the matplot library in Python?
Okay, so Power BI is a tool from Microsoft that helps you to kind of analyze and visualize data really well, and then be able to import data, clean it up in lots of ways, and in what's a tool part of Power BI called the query editor, then visualize it in lots of ways. We've just seen a couple of ways with bar charts and kind of strangely concocted donut charts and matrix. And then once you've done your analysis, built your visualizations, then you can come along and hopefully, I'm still sharing my screen. You can publish it to Power BI and to the Power BI service, and then people in your particular corner of Power BI, in your tenant, in your organization, subject to good security, they can use and interact with your visualizations and gain insight. So that's what Power BI is. Python, you mentioned Python, one of the Python libraries, what was it again? A matplotlib or something. That is writing Python code to build it. And so you don't need to learn Python code and for using Power BI. That's a kind of totally different audience doing that. I hope I have answered that question. Hopefully I have.
Christopher, do let us know if that.
Okay, and I'm just having a look at the comments as well.
Yeah, and then there's no questions, but comments, obviously.
Okay, so what I'm doing is I'm just bringing up a proper Monte Carlo method, a one typical. Let's get away from this. It's just Power BI is just taking some time to come up. I've got those things. I'm just going to, while it does, I've got what I'm going to show you is a financial model here. Is maybe a company, and we're looking at the income statement for a company when it comes up. I'm waiting for it to come up. It's coming up on the screen, and the company is making widgets, and the financial statements, well, just like the spinner, we might have some random variables which are the corporate tax rate. Now, give me 1 second and let me just bring this in here. Let me just bring this onto my. Hopefully, you can see this. Come on, up you come. Can you see Power BI? So what we've got is we've got a model here, and we've got a. Let's have a quick look at our company-based data. We've got some data, and we've got a company. Let's have a quick look at this. And so what we've got is a company that's got revenue of 10,000, cost of goods of 30,000, bank loan of 5 million, fixed costs. And what we're trying to do is we're trying to do a Monte Carlo trial. And what we're saying is that in this Monte Carlo trial, just like we had the spinning wheel, we don't know exactly what the bank rate will be. So I've said that in this case, the bank rate that we have to pay, the interest on our loan, is somewhere between a minimum and a maximum. I've drawn 6.5% and 7.5%. The inflation rate is based on a normal curve, which is somewhere between whatever I said, 7%, give or take 2% as standard deviation, and the tax rate. Jeremy Hunt is just in a budget, but I'm saying that the tax rate is based on a discrete distribution, 30% likely to be 19%, 60% likely to be 20%, and 5%, 10% likely to be 26%. And those are our spinning wheels in this. And so we're doing exactly the same. This is exactly the same sort of calculation as we did to spin the wheels, but a much more kind of serious one. And what we do then is saying, given that we've got a calculation for our net profit, and if we run that what we can see is we run it, I think, 10,000 times, and we can see that for most of the times we are going to break even. That's the green bars there. But we can see there's a certain percentage of times where the company is going to make a loss. So what we can do there again, and on the right, I'm just showing those distributions. This distribution here is more like the Monte Carlo wheel. It's a kind of uniform distribution, and we can see it could be any number between 6.5 and 7.5, between 6.5 and 7.5. This is a discrete distribution. It can only be three values, 19% or 20% or 26%. It could never be 21, 22. And this is a normal distribution. We're saying our interest rates are likely to be 12%, which is here, give or take a standard deviation of 3%. So what we've done there is we've used Power BI to build this model on top of a kind of financial statement and say, okay, the financial statement is typically one result, the kind of deterministic result. But what happens if inflation changes? What happens if our bank rate changes? And what happens if the Chancellor changes the corporation tax again? Great, thanks for that. Any further questions?
So I'm not sure if you saw, but this there's a question which says, I noticed some tables refresh when there's a user interaction and some tables when you click refresh report. Which applies to which generated table?
Okay, so what we're doing here with Monte Carlo trials, let's go to this, is we're using DAX to create a calculated table that simulates a Monte Carlo trial. Now, when that's a DAX table, and that DAX table will be created when we click on data refresh, or typically when new data is brought in. So when we load data, a scheduled refresh, that's a data refresh. So calculated columns and DAX calculated tables happen once. Other things like the measures that we calculate. So for example, if we have a look here, have I got a measure on here? If we have a look at that, so we've got number of trials. Measures are calculated when there's a change to a filter. So let's just show that. So for example, what I'm going to do here is I'm going to come along and I'm going to say, basically, I'm going to come to my here, and what I'll do is I'll come and I'll just go to my Monte Carlo trial results, and I'll just bring in, for example, actually, I'll go to this one and I'll just come to the filters on this visual and I'll say, actually, we'll look at it when the net profit margin is less than 3%. And I'll do 0.03. So if I click on apply filter, what's happened there is that the measures have changed. So it recalculated those measures. In fact, it got rid of some measures because it was just a slice down here. But there was no change to my Monte Carlo trial down there. That hasn't changed. That would only change maybe once a day when we bring in new data and need to recalculate the whole thing. So that's the difference between a calculated table and a calculated column, which only changes when we refresh the data. Again, I can click on refresh and that will refresh the data. But that the refresh doesn't happen when we just change slicers or we just change filters in the filter pane. Hopefully that's answered the question. So Christopher Rogers got a question. Is Power BI limited to using VBA, or can you use two different languages? Well, Power BI doesn't use VBA at all. And there are two languages in Power BI. The language that we're seeing here is called DAX. It's a calculation of Power BI. And that allows us to create all sorts of simple or more complicated measures for our visuals. And then there's another language. If I click on transform data, which I'm not showing here, if we go to part of Power BI called the query editor, this is where we import data. Now, this is a really unusual case that we're seeing because what I'm doing is I'm not importing any data. This is an unusual use case. I'm actually generating it from scratch. But if we have a look at here, basically, and I click on Advanced Editor, this is another language. This is called M. We never really need to see the language, so we never really need to go into the Advanced Editor. what we can do is we can come along and we can use the UI here to basically, what we're doing it is to kind of bring in data, import it, clean, merge, pivot, unpivot, shape our data so it's in good shape for visualization. So no VBA, but 2 different languages, DAX for our calculations of our measures and our calculated tables, things like net profit, and M, which is used behind the scenes to import, shape, clean our data. Great.
Great. So no more questions there.
Okay, just to remind everybody that if they want to have a look at this, I'm going to share my screen. If I come over to, and I'll put this in I'll make this available, but the 2 Power BI files that we've used to calculate pi to simulate the roulette, they are on GitHub. If you go to GitHub and search Mark Wilcock, you'll find them. Just search for Power BI plays roulette, and you can come along there. And if you want to, you can come along and you can just download them. Well, you can download them. Good. Lovely, and I think that's it for me. Thank you very much for your attention, and I hope you've enjoyed this. I say it's a very unusual case study, but I think that Monte Carlo is a very useful technique, one I've used many times. And I hope with the final example, even though we kind of glossed over it, that you've seen that it can be a very powerful technique, especially for looking at financial models where perhaps some of the inputs, like inflation, we have an idea of the range of values that it could be, but not the exact value. And we can work out what our kind of results are.
Great. Thank you so much, Mark. And thanks everyone for joining. And we shall see you. We have this evening, we have another session, but yeah, see you around. And thanks, Mark. Have a great rest of the day. And thank you, everybody.
Thanks, everybody. Thanks for coming. Take care. Bye.